Take a look at adding rational expressions. So I want to combine 1 over y plus 6 plus 4 over y minus 3. Now before I can add these things, they need to have a common denominator. So just taking a look at how this worked with numbers, if I wanted to do something like add 1/2 and 1/3, I would need to have the same denominators in order to just add those numerators together. So I'm often looking for something that both of my denominators go into. So 2 and 3 both go into 6. So I could try to make this first fraction, leaving myself a little bit of space here. I'm going to try to make this first fraction have a denominator of 6, and the second one to also have a denominator of 6. Now, the only way you can change the denominator of a fraction without changing the number itself is you have to multiply both the top and the bottom by the same number to keep things balanced. To make a 2 look like a 6, I'd have to multiply the top and bottom of this by 3. 1 times 3 would give me a 3 in that numerator. 2 times 3 would give me the 6 in the denominator. Now if I'm looking at this 1/3 to make this 3 look like a 6, I would have to multiply the top and bottom of this thing by 2. 1 times 2 would give me a 2 on the top. 3 times 2 gives me a 6 on the bottom. Once I have the same denominators, in this case 6, I can just add those tops together, 3 plus 2 giving me 5, while leaving the denominator the same. So, quick observation, it's not that uncommon to see sort of these missing denominator pieces show up. The 2 was missing the 3 was missing the 2, as kind of a setup step to get a common denominator. So I'm going to do something similar here. This has a y plus 6 component to it, but it doesn't have a y minus 3. This has a y minus 3 component, but it doesn't have that y plus 6. So first thing I'm going to do is find a common denominator. I'm working in my vertical form here, so I'm going to line up my equal signs as I go. And I'm thinking of these things as sets. So denominators on their own here are already grouped. So you could put parentheses around this if it helps you visualize this. The y plus 6 is kind of linked together. So my first fraction is missing this y minus 3 component. So I'm going to multiply the top and the bottom of this fraction by y minus 3. I'm going to do something really similar for the second fraction. 4 over y minus 3, that's what I'm starting with. This is missing the y plus 6 amount, so I'm going to multiply the top and bottom of this expression by y plus 6. And I'm going to go ahead and do this multiplication. I'm going to do 1 times the y and 1 times the negative 3. So I'm going to have 1y or y minus 3. And for this other piece, I'm going to have 4 times y, so that's 4y. And that's a positive because I have a positive multiplied by a positive. I also have 4 and the 6 giving me 24. Now that I have a shared denominator of y plus 6 and y minus 3, I can combine the tops just by adding them together. Now I might be able to simplify this some more, so let's see what happens if I combine my like terms. Y and 4y is going to give me 5y. And 24 take away 3 is going to give me 21. In my denominator, I still have y plus 6 and y minus 3. Sometimes when I'm simplifying, say this was the number 3 instead, I might be able to factor further. And in some really lucky situations, I might actually be able to cancel things out in the numerator and denominator. That's not really the case here because 5 and 21 don't have anything in common. So I would stop this problem right where it's at. If you want, you can multiply out the denominator, but there's something nice about being able to see the restrictions of the domain. I wouldn't be able to plug in -6, and I wouldn't be able to plug in 3. So when I'm adding rational expressions, find a common denominator, add the tops, and then simplify as much as possible. Hope you found that useful. That was adding rational expressions.